Today I will be showing you how to do an ANOVA from chapter 12 of the textbook. ANOVA stands for Analysis of Variance. It's used to evaluate mean differences between two or more treatments. It's a form of hypothesis testing, and there are 4 steps which are taken from the chapter. We'll be doing an example after I explain the 4 steps and give some basic terms that you'll be hearing during this video. So step 1 of the hypothesis testing would be to state the hypotheses and specify the alpha level. There are 2 hypotheses that we'll have to state, which are the null hypothesis and the alternative hypothesis. And step 2 would be to locate the critical region. You'll hear about the degrees of freedom, which is the number of values in the final calculation of a statistic that are free to vary. You'll also hear terms referring to between treatments and within treatments. The between treatments refers to the differences from one treatment to another, while the within treatments refers to the differences that exist inside of the individual treatment conditions itself. Moving on to step 3 would be to perform the actual analysis. We'll have to analyze the sum of squares, the degrees of freedom, as well as the mean of square deviations, which is represented by capital M, capital S. And the mean of square deviations is referring to the variance of the treatments. The final step, step 4, would be to make a decision about the null hypothesis, whether we reject or fail to reject it, and to state a conclusion. And this HO here, which will be stated in the next slide as well, represents the null hypothesis. The example we're going to be doing is presented on this slide. The data for this example will be given on the next. An educational psychologist studied 3 types of books: paperback, hardback, and ebooks. 3 samples of students were given a particular type of book, and the number of miscues committed by each participant was recorded. So there will be 3 treatments. Treatment 1 is the paperback books, treatment 2 are the hardback books, and treatment 3 would be the ebooks. And the numbers under the treatments heading are the miscues that were recorded from those books. I went ahead and figured the mean values for each treatment, as well as the t-values, which is the sum of the miscues, and the sum of squares for each treatment. I also gave you N, which is the total number of participants, G, which is the sum of the E values, and also the sum of X squared in the treatments altogether. Take a minute and either screenshot this data or write it down, because you'll all be needing it to do the next steps. Step 1 to start the analysis would be to state the hypotheses and specify the alpha level, as we said previously. The null hypothesis for this example would be, again, represented by HO. It would be the mean of treatment 1 equals the mean of treatment 2, which equals the mean of treatment 3. You could interpret that as the type of book used has no effect. The alternative hypothesis for this example would be represented by H1, and that could be at least one of the treatment means is different from the other. And the alpha level that we're going to use for this example is 0.05, which is typical of ANOVAs to use. Moving on to step 2, we locate the critical region. I've highlighted the equations in blue that we're going to have to use to define the degrees of freedom. And once again, we have df between and df within. Df between equation is take k, which is the number of treatments, minus 1. So we have 3 treatments. Take 1 away and you get 2. Df within is in total number of participants minus k, number of treatments. Plug in those values and get 12. Now to find the critical F value, we look at table B4, which is in the back of the textbook on page 577. It's a table. At the top, you will find the DF between number, and on the side, you'll find the DF within number. Match those up, and you find the critical F value for an alpha level of 0.05 is 3.88 for these degrees of freedoms. So 3.88 would be our critical region, and you'll find out how that affects the example in the last slide. Moving on to step 3 would be to perform the actual analysis. We will have to start with sum of squares. Once again, I highlighted the equations in blue. We'll be finding SS total, SS within, and SS between, SS referring to sum of squares. For SS total, we take the sum of x squared, which was given to you on the data slide, minus g squared, also given, divided by n, which was also given. So take those numbers, plug them in, and you get 46. For sum of squares within treatments, we would take the sum of squares from each treatment. So we take 8 from treatment 1, 12 from treatment 2, and 16 from treatment 3, and get 36. Now for SS between, you will take the sum of squares total minus the sum of squares within. So take the two previous values we just found and subtract the 36 from 46 and get 10. The next part of step 3 would be to analyze the degrees of freedom. So we have already found the degrees of freedom between treatments and the degrees of freedom within treatments. We have to find the degrees of freedom total, which is once again shown in blue. To find the degrees of freedom total, you will take the total number of participants, or n, minus 1, and get 14. Then once again, you would go ahead and state the DF between and DF within again. You'll be using the data from the sum of squares and the degrees of freedom in the next step, which is to calculate the MS values, or the mean of squared deviations, as was said earlier. So for MS between, we'll take the sum of squares between divided by the degrees of freedom between, 10 divided by 2, 5. And for MS within treatments, we would take the sum of squares within treatments divided by the degrees of freedom within treatments and get 3. For the final step of step 3, we would compute the F ratio. And to get the F ratio, you'll take the data that we previously figured, which is the MS between over the MS within. So MS between in the numerator, MS within in the denominator, and take 5 divided by 3 and get 1.67. So our F ratio for this example is 1.67. And finally, the final step of the analysis is step 4, make a decision about the null hypothesis and give a conclusion. So we found the F ratio for this example to be 1.67, and our critical region was 3.88. Now since 1.67 does not exceed 3.88, it is not in the critical region. Therefore, we have failed to reject the null hypothesis. Now if 1.67 was greater than 3.88, say we found a higher F ratio, we would have rejected the null hypothesis. But in this case, since 1.67 does not exceed 3.88, our critical value, we have failed to reject the null hypothesis. We can interpret that as the type of book does not have a significant effect on the number of miscues committed by our students that we observed. And finally, the information highlighted in red would be how you would present or report the findings from this ANOVA. So the F ratio of our degrees of freedom 2 and 12 equals 1.67. P greater than 0.05 since we failed to reject the null hypothesis. And that is how you do the ANOVA.